Guys, welcome to the third lecture of engineering thermodynamics series. Today we'll be discussing about the properties of system or thermodynamic property. And before that, going to the thermodynamic property and all, which are the which is actually the thermodynamic property of system. So before that, we should know what is the state of a system. So it's an equilibrium condition of a system. Okay, so to define, let me write this way. To define state of a system. So to define a state of a system, we need a thermodynamic property. Alright, so to define that thermodynamic property, we need the state of a system. Okay, let me explain the state and all. First, you should know the thermodynamic properties there are so many thermodynamic properties, but for your convenience, let's say volume, okay, pressure. These are common things, so I'm writing this for the first instance. Temperature, there are other properties also, but let's say these are the thermodynamic properties, then the volume, pressure and temperature. Okay, let me explain this way. Suppose this is a cylinder piston arrangement. Okay, so let's say it is at this state. This is state 1, and after some time, after going down, the piston position in the cylinder is this state, state 1. At state 1, let's say pressure is 2 bar and temperature is 50 degree, and at state 2 the pressure is, let's say, 2.5 bar and temperature is 53 degrees Celsius. Okay, so see, at the first instant, that first instant is called state 1 and the second one is called state 2. So to realize the state, we need to describe it using pressure and temperature. I haven't used the volume here. As you can see, it is changed from 2 bar to 2.5 bar and 50 degrees Celsius to 53 degrees Celsius. So to understand thermodynamic property, we should also understand what is state of a system. So it is nothing but the equilibrium condition. Okay, let's move further. Okay, conditions to define the state of a system. Condition to define the state of a system. The first condition, it should be the properties should be uniform. Okay, should be uniform. I'll explain this. Let's first write the thing. Uniform throughout the system. They should, second one, should be invariant. Invariant means not changing with time. Okay, so let me explain in this way. Let's suppose this is a container and there is a pressure of 3 bar. Then in the entirety of the 4 walls of this container, let's suppose there are pressure points. In all those points, the 3 bar should be uniform throughout. Okay, and it should not change with time. So let's say this is state 1 and the state is not changing. And let me tell you one thing, when state changes from state 1 to state 2, this is called process. If there is a change in state, this is called process. Okay, we are talking about a single state. In that thing, if the process is not happening, means it's not changing to the state 2, at that case, in that particular state, the properties, let's say we are talking about here the pressure. Okay, pressure is 3 bar. It should be uniform throughout the system. Let's say these are the 4 walls of a container, and that's the system, and the 3 bar is uniform, and with the time it is not changing. Then only we can define the state of a system. And as you know, why do we need thermodynamic property? To define the state of a system. Okay, let's see, here also we are using the pressure. So to define the state of a system, since we are only talking about a particular state, not change in state, which is called process, simple, in a single state, to define the state of a system, we need a thermodynamic property. Since it is not changing, see, we are talking about here the pressure, so it's in a equilibrium condition in that particular state. Okay, and now these properties are of 2 types. First one is extensive properties, and the second one is intensive properties. Okay, so your first one, extensive property, these are the properties which are dependent on mass. Okay, these are the properties that are dependent on mass. Okay, mass of the system, dependent on the mass of the system. Okay, let me explain this to you. And before that, we should know what are the extensive properties. These are the volume, mass, internal energy, which we will be discussing in the upcoming videos, heat capacities, even though we have studied in class 11 or 12, and we'll be studying it again, heat capacity. Then entropy, entropy we'll be studying in the upcoming videos, what is entropy, and there are many others. Let's say these are the extensive properties which are dependent on what? Mass of the system. I will explain why. See, suppose there is this volume of the room which is V. Now the same room has been divided into 2 parts. So let's say this is another part 1 and this is part 2 of the same room. So your volume will be getting divided. When you can see a division of the things, you can simply consider, or you can say that property here, the volume, is an extensive property. In case of other property in the intensive property also, we'll see this. Okay, let me write this thing. So since you have studied the extensive property, it is dependent on mass of the system. So what about this? It is independent on the mass of the system. And what are the examples? Pressure. See, in this case we have used the room and the volume. I will use the same room and we will change the property with the pressure, and I will explain again the room theory. Okay, then pressure, temperature, and there are like viscosity. You will be studying in fluid mechanics. When I will be teaching you the fluid mechanics series, we will discuss what do you mean by viscosity. There are thermal conductivity. It will be in the heat and mass transfer subject. If I start that series also, we will explain what is thermal conductivity. and now also the stress. Okay, so let me explain this, the same room thing. Okay, see, suppose there is this room and there is a pressure, let's say P. So if you divide this room, the pressure will be not P by 2 and P by 2. The pressure, the same room, let's say it's a part 1 and then this is a part 2. Both the room will be having the same pressure. You can say also the temperature. If there is a temperature, let's say 27 degrees Celsius, here also it will be 27 degrees Celsius and it will be also 27 degrees Celsius. The temperature won't be divided like the volume has been divided. So if you cannot divide it, if it remains the same even after dividing the thing, you can simply say it is what do you mean? It is intensive property. Okay. And let me explain one more thing. In this intensive property, we can also write one more example, density. Yeah, let me explain this to you also. Okay, let's say as you know, density is what? Density is mass per unit volume, right? Let's say there is this container where the density of gas is like D. Okay, let's say D, and after dividing the container, what it will be like? Since I have said it has to remain as m by v, it cannot becomes d1 and d2 or m1 by v1 and m2 by v2, right? It should remain as m by v. If it is m by v, for that to remain as intensive property, so it should be all remain as m by v and it should be also remain as m by v. So how can it be? Because mass is a intensive property, volume is mass is an extensive property, right? Dependent on mass, and volume is also an extensive property. So extensive property divided by an extensive property, how can it be a intensive property? But density is an intensive property. Let's see. Let's say here in this case, let me remove this one. If we see, since there is a part 1 room and part 2 room, what is happening here? It will be m by 2 and it will be v by 2. What it will be then? See, it will remain as m by v. You are getting again m by v. And in this part also m by 2, because mass and volume are extensive, so it will be divided by 2, right? As we have did it in here, right? See, v by 2 and v by 2. So it will be m by 2 and v by 2, so it will also come as m by v. As you can see, it is not divided like this one, v2 v by 2 and v by 2, like, but it is something like the pressure remains the p in both the parts and temperature remains the T in both the parts. In case here also you can see your the density, that is mass per unit volume. Here it is also the part in the part 1 of the container it is m by v, and the part 2 it is also m by v. So we can say one thing, that intensive property is like an by dividing two extensive property we can get an intensive property, and vice versa. Extensive properties is equal to the division of two intensive properties. Okay. And one more thing that I should add up, any specific volume, if you add the word specific, like specific volume, specific density, specific mass, specific enthalpy, specific entropy and all, if you use the word specific, okay, specific, then these are all intensive properties. Let me explain with one of them. See, your volume, simply volume is V. But if it is specific volume, it will be divided by mass. in this in case of all the other intensive property with the word specific, all are if the density is again divided by m, or all the properties like the specific enthalpy, specific entropy, if it is divided, that property is divided by m, that becomes this specific things tells you about it is an intensive not intensity, it is intensive property. Okay, intensive property. So I hope you are clear with these two, and let me add up one more thing which we'll be discussing in other videos also, in our upcoming videos. Heat and work are not property of a system. Heat and work are not property of a system. They are actually functions, because they are I will be explaining in the upcoming videos also, because they are generated when there is a change of state 1 from state 2. Like when the piston goes up and down, it gives us a work, right? Piston goes from state 1, let's say pressure 1 bar, to pressure 2 bar, let's say, inside the cylinder. So there is due to the change in the state, which is called process, we will get a mechanical energy, right? Because piston cylinder arrangement gives us a mechanical energy. So when there is when it is related with process, so it like the heat and work, so it cannot be a property of the system, rather it's a it is actually function which we'll be discussing in the later videos. For now it will be considered in the term called process, but not in the property of the system, not right. So thank you very much for watching this third lecture. I request you all to subscribe and like and share this video with your friends. Thank you. Bye bye.